Okay, guys, I want to welcome you to class today. I'm excited about the class, and we're continuing with multiplication. Your notebooks should be open, as I previously stated, and the pencils should be out because we're getting ready to make sure that we have the right notes. So open your math notebook, and have your pencil out as we go. Turn to the page where you have taken notes in this class. Have you taken notes in this class before?
Yes.
So turn to that page so you can see what it is. And read to me what you took before. I know you spelled the word multiplication. What else did you write down?
It's just.
You wrote down the definition that it's super fast addition.
Yeah.
Very good. Okay. And what else did you write down? Anything? 3 plus 2 equals 5. And anything after that?
3 times 2 equals 6. And then the adding sum and then the back.
Very good. All right. That's what we're getting ready to review right now. If you don't have those notes in your book, make sure that you put them in your book as we go. And then we're just moving forward today. All right. Here we go. Multiplication, everybody, is just what? It's just really fast addition. It's super fast addition. What do you need? What do you need? What do you need?
Nothing.
Oh, okay, because your arm was up. Okay, thank you. Moving on. Now we have this equation 3 plus 2 equals 5. You already have that in your notes, but if you don't have it in your notes, please put 3 plus 2 equals 5. Woohoo! All right. 3 plus 2 equals 5. We already understand that the 3, the 2, and the 5 are digits. Say digits.
Digits.
Digits. In fact, you can write that word down. D-I-G-I-T-S, like dig it. Dig it. I dig it, man. Digits. D-I-G-I-T-S. D-I-G-I-T-S. Digits. The only digits that exist in the whole wide world are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Those are the only digits that we have. That's it. Because then we use those digits in combination to make any number in the world. We don't have any other digits other than that. We have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Those are the only digits that we have. And we use those digits to make any number in the world, which I think is really cool. That you can have those 10 digits, and there are 10 because there's a 0. We use those 10 digits to make any number in the world. If you're singing or humming or making that noise, please stop. Thank you for your cooperation. All right. Oops, still doing it. We're moving on. So we have the digits. These are digits. And when we take them and put them somewhere, then they have a value. That's why we call it what? Place value. First you have place, then you have value. All right? You can't have value without place. When we take the digit, and let's just say we're taking that 3, and we put the 3 in the tens place, how much value do I now have? Because I'm living in the tens place right now at this moment. How much value? Tell me.
30.
30. Very good. But if you move me over to the thousands place, how much value do I have now?
3,000.
3,000. 3,000. Very good. But if you move me back down to the ones place, how much value do I have now?
3.
3. So for these digits, first they have to have a place. They have to be living somewhere. In the ones, tens, hundreds, thousands, 10,000s, 100,000s, millions, in some place. They have to be living, and then they have value. That's how their value is determined. All right, but if you are a good math detective, if you are paying attention to strategies, if you are looking around at stuff and paying attention, you are going to realize that this math problem is bossing you around, it's telling you what to do, and it won't hush. It's telling you more than enough to find your answer. For example, it's telling you what to do. What type of math is it telling you that you will do?
Addition.
Addition. That's kind of sad. Come on, guys. What type of math is it telling you?
Addition.
Addition. Everyone should be looking this way. Some of you are still looking at yourselves in the computer screens, and you're looking like it's a mirror, and you're sticking out your tongue and doing things, looking at all that. Please don't do that, or I'm going to call your name, and then you're going to be embarrassed. And I can tell if you're doing it because I can see you doing it. All right? So please don't do that. It's addition. It's bossing us around. It's telling us, You will add. Oh, yes, you will. Is it giving us the choice to subtract?
No.
No. Is it giving us the choice to divide?
No.
Is it giving us the choice to multiply?
No.
No. It's telling us we will add. So that's kind of bossing us around. But that's good news because it's telling us what to do. If we didn't know what to do, it's telling us what to do. What do you need? Your teacher's already told me that you cannot leave this room and you have to stay here with me. So I'm going to say smile and make the best of it because you're in here with me until our time is over. So if you will think about what I'm doing and focus on that, that will help you to overcome whatever it is that's troubling you right now. I promise you that it will. But there's nothing, right now you have to stay where you are, and that's just what we have to do. And it's going to be okay. You're going to be all right. You're safe and you're going to be okay. Everybody else is focused on what we're doing. It's telling us what to do, and it's also telling us too much. For example, if I cover this up, is it possible to find the answer to the problem?
Yes.
Yes, it is. You know why? Because it's talking to us, it's telling us too much. Bristol, focus right here with me. Thank you so much. What if I cover this up? Is it still possible for me to find the answer?
Yes.
Yes, it is, because I'm counting 3, 4, 5. There's my answer, I have it. If I cover this up, is it possible to find the answer?
Yes.
Yes, but if I cover this up, is it possible to find the answer?
No.
No, because first of all, I don't know where I'm going. I have no idea when I'm going to stop. I don't know if it's a large number or a small number. I have no idea. So if we cover up too much information, we can't ever find the answer. But math problems are friendly that way. They're really nice, and they're a little chatty. They'll chat. They'll talk a little bit too much. Don't raise your hand if you're sitting next to a friend who talks a little bit too much. But sometimes they talk a little bit too much, but they talk enough to tell you how to do the problem. So they're bossy, and they tell you enough information to help you do the problem. These have formal names, the 3 and the 2, because they're living in an addition equation. What are their formal names? You should be able to tell me by looking at your notes. Everybody say it together. Add in plus add in equals sum. Very good. And we have it right here again, add in plus add in equals sum, and we're moving on. We're following the math signs, and I think last week I played the movie for you, the dog movie about the math detective, did I? And so we played that movie last week about being a great math detective, and we don't have to worry about that because we are math detectives. Let's stand and do our math scholar rap just really quickly. Woo! Everybody standing up. Get it up, get it up, get it up. All right, no pencils in your hands. Don't want anybody to poke anyone. Remember, this is your learning opportunity of scientifically to learn because we are singing it, saying it, our ears are hearing it, we're moving with it, it's a song type thing, and we're creating muscle memory, and we're crossing the middle part of our body. So here we go, everybody doing it together. Please be careful there that you don't bang into that. Thank you so much. Here we go. I'm a math scholar, I've got something to say. Multiplication facts are coming my way. Not too tired to learn, not afraid to shine. Multiplication facts are gonna fill my mind. Gonna keep them, not lose them, they're here to stay. Multiplication facts I'll use every day. So jump back, Jack, and step up, Sally. There's no time to dilly-dally. I'm a math scholar, getting it done. Learning multiplication facts with tons of fun. Multiply. 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 Yes. Awesome. Good job. Have a seat. Very, very good. Fantastic. Now, as a quick review, we have a different equation. How do I know it's different? It's got the 3 and the 2 in there. What makes it different? Everybody, tell me the answer. What makes it different? Say it.
Multiplying.
It's multiplying. How do you know it's multiplying? Because there's an X in there. Show me the 3 signs to multiply. X, dot or asterisk, right? And what's this called?
Parentheses.
Parentheses. Very good. If we see any of those signs, what type of math are we doing? What type of math? Multiplication. Very good. So we're being good math detectives. We're following the signs. We know we're multiplying. And now, even though multiplication is super fast addition, Now their name has changed, just like me. When I'm here at school, I'm known as teacher. When I go home, I'm known as mom. When I'm out in the community, I'm known as friend. So I have different names depending on where I am. So this 3 is now living in a multiplication equation. It has a different name. What do we call it, everybody? Factor. So let's read it that way. Factor times factor equals product. Very good. Factor times factor equals product. If you don't have that in your notes, please write it in your notes. We did that last week. Factor times factor equals product. Very important that you know that terminology, because on a test you might have something that says using the factors 7 and 2 provide the product, or what is the product? Please give the product. And if you don't know the terminology, you're not going to know whether to add 7 and 2, multiply it, divide it, or subtract it. So you have to know the terminology. Very good. Moving on. Now here's the big question. What does the first factor represent? Everybody should be able to tell me. Say it together.
Group.
Yes, I love that. The first factor represents groups. Let's do it together. Let's do our strategy. The first factor represents groups. All right, everyone should be doing it. Some people are playing. They're not doing it. Let's try it again. The first factor represents groups. Now, I'm holding my arms out here. I can see the group. I can see myself making this. This is a strategy. Remember the Math Detective movie says, first I use my favorite strategy. So if you're asked to represent an equation, you don't have to go, represent, what does that mean? I don't know. How am I supposed to do that? I don't know. What is that? What? No drama. We just go right to our strategy. The first factor represents groups. So I know I immediately start drawing groups. And then I draw the number of groups based on the number that's in the equation. That's what I do. Moving on. What does the second factor represent? Everybody.
The number in each group.
Oh yeah, let's do it together. The second factor represents how many are in each group. Sweetheart, I called your name earlier. I don't want to call it again because I am videotaping. And I know you to be a more involved student than you're choosing to be right now. So I'm expecting you to do this with us if you don't want to blow the line. Let's do it. Here we go. The second factor represents how many are in each group. Say it again. The second factor represents how many are in each group. Make sure you cross the middle of your body when you're doing that. And what are we doing? We're stamping. We're stamping how many are in each group. And as we go on to that, we can actually see it. Here we go. How many are in each group? What factor tells us that? The second factor. Is that number always 2? No, it could be any number, right? That's how many we're going to put in each group. Very good. Moving on. In your notebook right now, represent 6 times 3 for me. 6 times 3. So I'm not going to tell you what to do. It says use your strategy. And you have a strategy. You know the strategy. Represent it, and after you get it represented with a product, so please don't write the equation and then just give me a product. That's not what I'm asking you to do. I'm asking you to represent it. And we've been using a strategy where we use the word represent. You should be able to make that connection, and you should know exactly what to do. You should know exactly what to do. And when you get it, hold it up and show it to me. Yes, and hide it. Do you have a product? Do you have an answer for the total? Did you put one? Okay, I can't see from that far back. Looking good, looking good, looking really, really good. Woohoo! Whoop, 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 whoop. Very good. All right, so you can go ahead and put those down. So let's talk it out. If you're representing, what did you draw first to represent? Because to represent it, you either have to draw it or you have to have math manipulatives. And since we don't have manipulatives in front of us today, we are drawing it, right? So we're representing it, we're showing it, we're demonstrating it. What was the first thing you did? Tell me.
Groups.
You did the groups. Why? Because the first factor represents groups. How many groups did you make?
6.
6 groups. Very good. All right, what did you do next?
We put how many?
You put the dots in there. How many are in each group? Bless you. How many are in each group?
3.
3. 3 are in each group. That's right. 3 are in each group. So we put 3 in each group. Very good. And you got your product, which was what?
18.
18. We skip counted by how many? Were we skip counting by 6 or by 3? 3, because there were 3 in each group. So let's do it 6 times. Here we go. 3, 6, 9, 12, 15, 18. The product is 18. Much faster than just counting 1, 2, 3, 4, 5, 6. Again, that's what multiplication is. All right, let's talk about properties. Properties. Have we gone into real estate over here at Mount Pleasant Elementary? Am I teaching real estate? Are we going to buy some homes and renovate them and sell them and do that? Do we need to call the property brothers, Drew and Scott, and get them over here and get them to figure it out for us and all that kind of stuff? Is that what we're talking about when we say math properties? Anybody have any idea what this word properties is referring to or what it means? What do you think, sweetheart?
I think it means like the things that you can do with multiplication.
Yes.
Kind of like the laws.
Yeah, very cool. Very cool. Like the laws, like the things that you can do inside multiplication. The parameters or the fenced areas or the rules or how you can navigate, how it can be easier for you, what you can depend upon, things that happen. For example, we have laws of like gravity on Earth. I could pick up this book that I'm getting ready to read to my kindergarten class. I could pick up this book and if I hold it and if I let go, guess what it's going to do?
It's going to drop.
There's no mystery there, right? It's no surprise that it's going to fall to the earth, right? It's going to fall to the ground. That is not a mystery or a surprise. Why? Because gravity is like a law. It's going to happen. Inside multiplication, we have some things that we can depend upon as well that are going to happen. One of those properties is zero property. Zero property. Please write it down. Zero property. Inside your notebook. Zero property. We've got zero property. We've got a zero property here. We've got zero property. Zero property. Sounds really fancy schmancy, but it really has an easy meaning. Zero property means any number. All right. Any number. Does that mean number 4?
Yes.
Does it mean 1,398?
Yes.
Does it mean 0.37? Yes. Any number multiplied. Oh, is it added? No. Is it subtracting? No. Division? No. Multiplication. Any number multiplied by 0 is going to equal 0. All right. Here we go. Let's do this together. So this is a little thing so we can remember. Pencils are down. We don't want to poke ourselves. Get out your zero looking glass right here. We're going to put it up and we're going to say zero property. All right, right here, gentlemen. You're both doing it with us. Here we go. Zero property. And we're looking around. All good. All right. Any number. Do it with me. Any number multiplied by 0 is equal to 0. We're going to start out where we began with the looking glass. 0. Absolutely 0. All right, let's try it again. Zero property means any number multiplied by 0 equals 0. All right, and I want you to do it with a little attitude. All right, like you've kind of got that, I don't know, I don't want to pick on Italians, but that kind of, yada yada kind of thing going. All right, here we go. Are we ready? Zero property means any number multiplied by 0 is equal to 0. Excellent. One last time. 0, and make sure you say this part first because that's the whole sentence and your brain needs to remember the whole thing. Zero property means any number multiplied by 0 is equal to 0. Very good. Now let's live it out. Let's prove it. If we represent 6 times 0, go ahead in your notebook and represent that. 6 times 0, write down 6 times 0 underneath your zero property word, your title that you already put down. If you represent 6 times 0, go ahead and represent it. It won't take you long to represent it. Yep. I love representing 0 property. It's so much fun. Oh yeah. Oh yeah. Okay. Did you put a product on there?
Yeah.
Equals. Okay. Books are down. Good job. All right. So using our strategy, right, to represent, the first factor represents the number of groups. How many groups do we draw right here? 6. You should have drawn 6 groups. If you didn't, do it now, because I asked you to represent this. You should have used the first strategies that we learned. The first factor represents the number of groups. And then you would have gone to the strategy that goes with it, which is the second factor represents how many are in each group. Well, when you got ready to do that, what did you do?
Didn't do anything.
You didn't do anything. You left the groups completely empty. So this means that we have 6 groups with nothing in them, so we have absolutely nothing. Boom. There it is. Okay, we have absolutely nothing. Huh. All right, so let me ask you, what is 1 times 0? Say it.
0.
What is 4 times 0?
0.
12 times 0? 9 times 0? 8 times 0? 3 times 0? 2 times 0? 11 times 0? 8 times 0? 7 times 0? 10 times 0? All right. It's 0. Why? Because, let's do it. Let's do it. Here we go. 0 property means any number multiplied by 0 is equal to 0. Try it again. 0 property means any number multiplied by 0 is equal to 0. That's what 0 property means. Any number multiplied by 0. If there is a 0 in the equation, what's the answer? What's the product? Absolutely
Nothing.
0. It's absolutely nothing. Very good. Excuse me. Here's our representation, 6 groups.
Ms. Wooden,
Yes, ma'am.
Nathan Wyatt is being signed out.
Okay, thank you. Nathan.
Nathan's still in class. Oh,
Don't we have Nathan? No.
we got Walker Wyatt.
No, we don't.
We got Walker Wyatt.
We've got so is Walker being signed out?
There's Nathan.
I know. Hang on, let me tell her that I have Walker and not me. Hold on. Hey, I have Walker Wyatt and not Nathan. I'm sorry. Okay, all right, thank you. Okay, we got that fixed. So here we have 6 groups with absolutely nothing in any of the groups, which gives us nothing. And let's do this one more time. 0 property means any number multiplied by 0 is equal to 0. Very good. Moving on. Okay, now I want to do something right quick that is going to go with this 0 property thing. It's called commutative property. Think of when you get in the car with your family and you travel somewhere. Another word for that is commute. You're commuting to somewhere. You're traveling. So, gentlemen, please stop playing with your markers. And your book should be open where you're writing this information down. Commutative property. And I'm teaching you how to say it now. Commutative property. Thank you. Commutative property. You're writing it down. Commutative property. Commutative. Commutative property. And I like the traveling analogy. I like thinking about the traveling because that's kind of what happens in this case. Something travels. It moves. And I think it's kind of cool to think of it that way. That's how I can remember it. It's a simple way. Commutative property. Like I'm going to commute. I'm going to travel somewhere. Commutative property. All right, say it with me, because sometimes I've found that in math class, if I'm uncertain of the name, if I don't know how to say it, then I'm afraid of it. Have you gotten afraid of something that you couldn't say? That's reasonable, to be afraid of something that you can't say. Or to be shy about it, or go like, oh, well, it's that thing, I don't know, I can't remember the name. We give ourselves permission to not remember the name, but we can't do that. You have to remember the name. Commutative property, say it with me. Commutative property, say it again. Commutative property, say it again. Commutative property. All right, why don't you clap it with me? Commutative property. All right, we want to say it with accents on all those places. Commutative property. Try it again. Commutative property. Try it again. Commutative property. Say it again. Commutative property. One more time. Commutative property. Very good. Excellent. Now, commutative property means this. It means that if you switch the factors, so if I have the word factors, what type of math am I doing automatically? What do I know? Tell me. Multiplication. Very good. If you switch the factors in a multiplication equation, all right, we already knew that from the word what? Factors above. If you switch the factors in a multiplication equation, it does not change the product. What it's saying is it doesn't change the answer. It doesn't change the total. So if I say, attention this way, I know stuff's going on, looking at me this way. If I say if I say 8 times 0 equals, you should be able to tell me. 0 because of what property? Zero property. If I reach into that equation and I grab the 8 and I grab the 0 and I pick it up and switch it, and I put the 0 first, 0 times 8, guess what? The product is 0. It's still 0. Why? Because first of all, any number multiplied by 0 is 0, and all I did was switch the factors. Just like in addition, when you have an addition equation, if you have 3 plus 2, what does 3 plus 2 equal? Everybody? 5. You can also switch the add-ins in an addition equation, and if you have 2 plus 3, what is that going to equal? 5. So if multiplication is just super fast addition, this is what that is to addition. Anyhow, that might sound a little confusing, but the point is, commutative property allows you to switch the factors and it doesn't change the product. It doesn't change the answer. It doesn't change the answer. All right, put everything down and stand. Okay, we're going to pretend to be robots. You can do that well, I'm sure. We're going to put out our arms. Very good. We're going to say commutative property. Okay. All right. Commutative. And you don't have to say property now. Commutative. Oh, I want your best robot. Come on, give it to me. Bring it. Bring the robot. Bring it. Commutative. 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 Okay, good. Now that you're saying that, now we're going to represent commutative property with our movement. So we're going to say commutative, commutative. What did I just do? I picked up the factors. Commutative. What did I just do? I switched the factors. Commutative. What did I just do? I dropped them into place with them switched. Commutative. All right, that's one whole set. All right. Commutative, 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 commutative. All right, that's one whole representation of commutative property. Do you understand what we're doing? We're grabbing the factors. We're switching the factors. So if I have 7 times 2, I'm switching it to 2 times 7. All right? Now you give me the thing. If I have 3 times 6 and I switch it, what will it be?
6.
No, I'm not asking for the product. I'm asking what the switch factors would be. If I have 6 times 3 and I do commutative property, what will it be?
3.
3 times 6. And it does not change the product. It does not change the answer. All right, let's practice commutative. Commutative, 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 commutative. That's very good, but not everybody's doing it. Everybody's doing it. Here we go. Commutative, 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 commutative. Very good. Try it again. Can you do it with a little like this? Can you do that? More like a robot? Okay. Let's see if we can. Here we go. Commutative, 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 commutative. Now, let me see if you could do it without me leading you. Let's see if you can actually do the whole definition. Here we go. Commutative, 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 commutative. That was excellent. Oh my goodness, that was really good. So we went, let's do it with me, commutative. All right, we did commutative. What did we do? What was that? Picking up the factors. Commutative, what's that?
Switching them.
Switching the factors. Commutative, what's that?
Dropping them.
Dropping them into the equation where they're settled now. Commutative, commutative, right? Because we can't really bring our arms down like this. We have to go back to where we were at the beginning. Very good. One last time. Here we go. Commutative, 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 commutative. Excellent. Let's do what we've learned so far today. Zero property means any number multiplied by 0 is equal to 0. Commutative, 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 commutative. Fabulous. All right. One last property for today. Are you ready? I think you could do one more. The last one is called identity property. Identity. Say identity.
Identity.
Identity property. Identity property, simply when we talk about identity, what are we talking about?
Me.
Me. My identity. Who I am. Who I am. Identity. Me. So I have a little thing with this. Peeps. There's only one me. It's my identity. All right. Just try it again. And that's true. That's really true. There's only one me. All right, here we go. There's only one me. It's my identity. Let's try it again. There's only one me. It's my identity. Now turn to your neighbor and say it to your neighbor who's at your table. Very good. All right, here we go. There's only one me. It's my identity. Now, I want you to say it with some attitude. And when I say attitude, I mean a little bit of head bobbing. I mean a little bit of like this kind of thing. And yeah, but not beating yourself, but with attitude, all right? Good. Bringing that down just a hair, just a touch. Bring that down. All right, so I want you to say it in that way. I want you to say it in that way because I want you to be adamant. Adamant means that you're not going to change your mind. Have you ever seen anybody go like, I am not changing my mind about that, all right? So I want you to do that because then I'm going to connect it to math and it's going to make sense to you. Okay, so here we go. There's only one me. It's my identity. That was so much better. Do it one more time with that same attitude. There's only one me. It's my identity. Very good. All right, now here comes the math connection. Any number multiplied by 1, that number stays the same. All right? So if I'm a 10 and you want to multiply me by 1, I'm like,
It's 10.
and there's only one me. It's my identity. I'm staying like a 10. You're not changing me for any reason. Or let's pretend that I'm 3. 3 times 1. Or what have we learned from commutative property? If I say 3 times 1, I can also say
1 times 3.
1 times 3. Let's try that again. If I say 3 times 1 with commutative property, I can also say 1 times 3. All right, so any way you look at it. If I'm 3 and you're trying to multiply me by 1, I'm like, there's only one me. It's my identity. Guess what? I'm staying at 3. Don't mess with me. There's only one me. It's my identity. It doesn't matter if it's 1 times 4, or with commutative property, what would that be?
1 time.
I just said, so you're not, no, you're wiggling and not listening. If I said 1 times 4, what will commutative property make that?
4.
4 times 1. Thank you so much. Fabulous. 4 times 1. Even if I switch the factors around, it doesn't change anything because any number multiplied by 1, that number stays the same. Any number. All right. What if I'm taking 0 and multiplying it by 1? Does 0 stay the same?
Yes.
Yeah. Zeros, there's only one me, it's my identity. I'm 0. Don't even try that on me. Don't try to make me 1. I'm 0. Okay? So, great way to remember it. There's only one me. It's my identity. Don't change me. Don't change me. Let's take a look at it. Let's prove it. 3 times 1. Okay? Is this a number? Yes. Are we trying to multiply it by 1? Yes. Well, this number is saying there's only one me. It's my identity. You're not changing me. I'm going to stay just like I was. I'm going to be what? 3. Just leave me alone. Leave me alone. There used to be this old Hollywood star, and she was called Greta Garbo, and she would say, "Leave me alone. Leave me alone. Leave me alone." She would, that was like her whole life. Leave me alone. I want to be left alone. Okay, well, that's what I think about whenever I see this. Leave me alone. I'm going to be a 3. Don't mess with me, all right? And if we were to draw this out, we would have 3 groups with 1 in each group. Think about it. Are we really multiplying or are we counting? We're counting. So basically when we multiply by 1, we're still just counting by 1. We're not skip counting. We're just counting by 1 when we do that. There's only one me. It's my identity. Which means what? Any number multiplied by 1, the number stays the same. For all of you sports fans who like baseball, you know how they go like safe, right? Okay? So you're safe. You stay just the same. You don't change. So with identity property, there's only one me. It's my identity. Identity property means any number multiplied by 1, the number stays the same. It's safe. It's unchanged. It does not change. All right? Very good. Excellent. That's really all we have time to do today. You've done absolutely fantastic. Let me see if there's any... yeah, but this is all proving it and commutative. We've done all that stuff. So here's what I'd like to do, just for you to be able to, as we collect things and relax and stuff, I'm going to play the happy movie for you. And we can play air guitar and all that kind of stuff. You guys may have a seat for just a second before she comes back, and you can pass things down to me. I'll come around and collect while you're enjoying this. Don't forget to sing it. In happy, I could get used to a brighter day. If I'm dreaming, don't anybody slap me. I could get used to living this way. You sure get used to living this way. Awesome. Okay, you keep singing, and I'll collect your stuff. Air instruments. I don't see anybody playing any air instruments. Awesome. Turn to your neighbor and say, "Have a nice day." Very cool. Thank you. Woo-hoo! You ready to play your instrument? Awesome, air fiddle. About my dog? I don't know what I'm talking about. right, air keyboard. Air guitar. You guys are doing great. Woo-hoo! Air keyboard.
It's like the only thing that you'll touch.
Any instrument. Yes, awesome. So I'd like for you to take that same happy